So far, I've been using GPIO to read a switch, the simplest of digital signals. Closed, the switch allows the full voltage, a digital 1. Open, the switch allows no voltage, a digital 0. But not all signals are 1s and 0s. For example, a voltage can be any number. This is known as an analog signal and is a problem because the Raspberry Pi doesn't have a way to directly read analog values. This requires the use of an analog to digital converter. There are many options, and in this case, I'm using an integrated circuit known as the MCP3008. This chip reads an input voltage and then sends it out through a serial peripheral interface. The Raspberry Pi has an SPI interface, and this is how I'll read that analog signal. A couple of notes about this project. This project is based on the 40-pin GPIO. It can be built using a 26-pin GPIO, but the connections will be different. It also assumes access to the SPI circuit on the Broadcom connector. Older models of the Raspberry Pi may not have this capability. Finally, the default Python GPIO library, rpi.gpio, doesn't include support for SPI. Instead, I'll use SPIDEV. Fortunately, this library is available in Python through a simple import statement. It is not available through Scratch. To connect the MCP3008 to the Raspberry Pi, I'll use these pins. Number 19, which is labeled MOSI, number 21, labeled MISO, number 23, labeled SCLK, and number 24, labeled CE0. The circuit I've built looks like this. I've included a copy of this schematic in the exercise files. The table on the right describes the connections that need to be made. There are 3 columns. The first column identifies a pin on the MCP3008 integrated circuit. The middle and right column identifies the GPIO pin and function. Each row represents a connection between the MCP3008 and the GPIO. For example, the first row identifies that the pin labeled VDD on the MCP3008 should be connected to the Raspberry Pi GPIO pin 1. This provides 3.3 volts DC to the integrated circuit. The only exception to this is the final line, labeled CH0 for channel 0. The channel 0 pin on the MCP3008 is not connected to the GPIO. Instead, it's connected to a signal. In this case, I'm using a photoresistor to control 3.3 volts. When I cover the photoresistor, the voltage goes down. When I let the photoresistor be exposed to light, the voltage will go up.